Hello and welcome to this little demonstration of MiniWorld. I created a small topology file with the core network emulation tool. You can see we have three nodes here, node 1, node 2 and node 3. They are connected via a Wi-Fi access point, and node 1 can see node 2 can see node 3, but node 3 cannot see node 1. And we are going to use this topology file inside MiniWorld. So let's have a look at the MiniWorld scenario config file. The scenario is named B.A.T.M.A.N Advanced because we are going to use the B.A.T.M.A.N Advanced routing algorithm. We have three nodes defined. We use a Debian 8 VM image where B.A.T.M.A.N Advanced is installed. The VM image has booted if MiniWorld sees the shell prompt root at MiniWorld inside the boot logs. There are some shell commands which are required to execute and start B.A.T.M.A.N. We have a link quality model which is named Wi-Fi exponential, which we are going to use, and the topology file we created with core is defined here, and we are going to use it in the Wi-Fi mode. This means that MiniWorld extracts the coordination from the nodes, and then the link quality model decides how the link impairment shall be. So let's switch to MiniWorld. On the left side we are starting the RPC server, and on the right side we are going to use the MiniWorld command line interface, and we are just starting the scenario config file I just showed you. You see we have three nodes, node 1, node 2 and node 3. Here the overlay images are created, and here you can see the QEMU commands. And now all VMs have booted. And you can see that the shell commands are executed on the appropriate nodes, and at the end some snapshots of the VMs are created to speed up further executions of the same scenario. Now that all VMs have booted, we can have a look at the boot logs, for example from node 1, and we can see that we have a Debian 8 image here and that everything went fine with the VM. So right now there's no network setup yet, but for that purpose we can use the MiniWorld command line interface, and we are invoking a step. This is a call to the RPC interface, and we can see plenty of things are happening on the left side, and right now we call finished. So let's have a look at all these statements which occurred. We can scroll back a bit. First we can see that the movement direct the coordinations from the core topology files. Then EB tables is used as a layer 2 firewall between the nodes. When IP route 2 is used to set up a bridge. The bridge is called Wi-Fi 1, and from each node the tab interface is added to the bridge. Node 1, node 2 and node 3. Moreover, B.A.T.M.A.N devices are set up. Afterwards, the link quality impairment is done with Linux traffic control. We are using HTTP to emulate the bandwidth. For node 1, we have a bandwidth of around about 3000 kilobit per second and a delay of 60 milliseconds, which is emulated with the NetEM kernel module. Of course, for node 2, we have the same link quality impairment, and since node 2 also has a connection to node 3, we have some additional link quality impairments here. Since node 3 is closer to node 2 than 1, we have a better bandwidth here and a reduced delay. Since we are using the bridged Wi-Fi network backend, this means that multiple connections can be multiplexed via one interface. We have to use some TC filters to redirect the traffic to the according class in Linux TC, and this is done with the following statements. And moreover, we can see here again that node 2 has two filters, therefore it has two connections. Afterwards, the IP addresses are set up on the nodes, and finally the connectivity is checked with the ping command. Node 1 pings node 2 and node 2 pings node 3. Okay, now the network is set up between the virtual machines, and therefore we can enter the shell of, for example, node 1. So we can see we have the B.A.T.M.A.N interface here configured with an IP address, and we can have a look at all neighbors of this peer. We can see that we are connected to node 2, via node 2, and also that we are connected to node 3 via node 2. Therefore, the routing works. So now we can have a look at the traceroute to node 3. And we can see here again that the routing works. For node 2 we have a delay of around about 30 milliseconds. This is since we have twice the delay of 60 milliseconds, and the delay varies a bit with 25% of the last delay. And for node 3 we have an additional delay of 16 milliseconds, which we can see here.